Welcome to Math 1324. This is section 6.3 on the dual problem. Alright, in question 1, we are given a matrix. So here's matrix A. And they want us to form what's called the transpose. It's a feature of a matrix, and it's pretty easy to form. So here's the process. So here's matrix A. We have row 1, row 2, row 3. To form the transpose, we simply take row 1 and it now becomes column 1. Take row 2, it becomes column 2, and similarly row 3 becomes column 3. And it's written with A with like an exponent of a capital T to denote A transpose. And we need this process to be able to form the dual problem. Okay. So in question 1, the idea is the following. We would like to minimize C, which is 2x1 plus 4x2. And we have some constraints, just like we did in section 6.2. We are in the first quadrant. It's x1, x2 greater than or equal to 0. And we have these two inequalities, which are intersection of lines. And remember, we wanted to maximize or minimize, and that occurred on the corner points. So the way we start this is we form the regular problem. Okay, so here's 6, 2, and 1. So 6, 2, and 1. We have 5, 6, and 8. It's there. So here's x1, x2. And now for the thing we want to minimize, we have 2, 4, and there's a 1 in front of the C. So that's 2, 4, 1. So we take that and then we form the transpose. Alright, so 6, 2, 1, the first row, becomes the first column. Second row, second column. Third row, third column. And with a transpose, we have new variables now, y1 and y2, instead of x1 and x2. By forming the transpose, it converts our problem from greater than or equal to less than or equal. And we now represent it with the y1, y2. So 6y1 plus 5y2 less than or equal to 2. And similarly for row 2. Now, with the thing we want to maximize or minimize, it now has variables y1, y2, and it is the letter P, just like in section 6.2. So that's where we're at. So now to get this in a table so that we can do our technique, we let x1 and x2 be the slack variables. What was this slack variable thing? Well, if we go back up a little bit, it's less than or equal to 2, less than or equal to 4. So I'm trying to add something in so that it would bring it up to exactly 2, exactly 4. So that's x1 here, x2 there. Now my last row, it looks different than what we saw here for P. So we simply get a 0, and now I move the y1 and y2 to the right hand side. So I get a negative y1, negative 8, plus P equals 0. If I put this in my table, my simplex table, Let's see. Here's the column for y1, y2, x1, x2, and p. So now just grab all the numbers. 6, 5, 1, 0, 0, 2. 2, 6. There's a 0 here. 1, 0, and a 4. -1, -8, 0, 0, 1, and a 0. And that's all they want us to do for this problem. They don't want us to solve anything. Now, this is a picture from our textbook, and it shows you what we're doing and why. So you see here, if we had an original problem, we'd be trying to minimize C. And we have an unbounded region. So the region extends off this way forever. So it's not going to have a maximum. It will have a minimum. And in this case, in this picture, it would occur at one of these 3 points. Well, rather than solve this problem, we form the dual problem, which makes the problem back like what we did in section 6.2. So here we're trying to minimize in 6.3. We convert to the dual problem, which is to maximize, and it would be at these corner points. And so, by doing that, we can solve the dual problem and then reinterpret it back to this unbounded problem to minimize. And this is in our textbook on page 319. Okay. So, in this case, they don't want us to do anything. They're just stating, here was the original problem. Okay, see our constraints, our unbounded place. They formed the dual problem, so we don't have to do anything. It's already been done. So here was the original. In red is the dual problem. And what they got is the final matrix. They already gave it to us. So the final matrix has been all cleaned up. We have an answer. And the question is, looking at this, what does it all mean? Well, looking at the last row, there are no more negatives, so we know it's done from section 6.2. What does it mean, though? Well, from the right-hand side here, the 3, the 3, the 261. What that means is the maximum of P is 261. And it would occur at y1, y2 of 3, 3. All right, but our problem, the one we really want to solve, is the minimization, and that's here on the bottom. So trace down the x1 and x2. So that's at 3, 6, and the minimum value there is 261. So they already solved everything. They just wanted us to get used to, okay, once we get there, what does it all mean? All right. So in question 4, we actually want to go through the entire process. All right, so let's do this slowly. So first off, form just the regular matrix A. 4, 1, 9. There it is. 3, 1, 2. Yep. And now for the C part, 19, 2, and 1. Easy enough. So now we go from there and we form the transpose. First row becomes first column. So 419 is now the column 419. 3, 1, 2, 3, 1, 2, 19, 2, and 1. Okay? A transpose. And now let's write down what is the dual problem. The dual problem looks like y1 and y2. Inequalities are flipped around. P, the last from the transpose here, we had 9, 2, and 1. So 9y1 plus 2y2 equals P. And we want to maximize that. So now, if we introduce the slack variables, x1 is here, x2 is there. So 4, 3, 1, 0, 0, 19. 1, 1, 1, 1. 0, but that's where x2 would go to make it equal. 0 and 2. What about the p business? Well, again, make it equal to 0, but keep p positive. So bring the y1 and y2 to the right. Okay, so here's the 0, goes right there. 1 for p in the p column. There's no x1 and x2, but I do have a minus 9 and a minus 2. Alright, so now we're to the process like we did in section 6.2. So the first thing I do is I look for the pivot column. How did we do that again? The pivot column came from looking at the most negative in the bottom row. Okay, so let's look for that. The most negative. The most negative here is this minus 9. So that gives me the pivot column. All right, so far so good. And so then I need to figure out, well, what is the pivot row? So I have a 4 and a 1. I take the 19 divided by 4, 2 divided by 1. So 19 divided by 4 is 4 point something. 2 divided by 1 is 2, and that's the smallest. So that becomes my pivot row. So now I want to use this 1 to make a 0 above it and a 0 below it. So I'm going to take minus 4 times this row, add it to the top row. So here it is, minus 4 all the way across row 2. Here's row 1, add them up, and that's my new row 1. What about the minus 9? Well, let's see, 9 times row 2, add it to row 3. Alright, so here's 9 times row 2 all the way across. Here's row 3, add them up. And now this is new row 3. And so now let's put everything back. Here's the new row 1. Here's row 2. Here's my new row 3. So let's see, looking at that, there are no more negatives in the bottom. We're done. So what does it mean? All right, remember, here's x1, x2. So the minimum value is this 18. And it's at the point, which point? Well, for x1 is 0. For x2 is 9. Okay, so it just appears in the bottom row. Label your columns so you don't get confused as to which one is x, which one is y, and which one is p. Alright, so we get a little more practice and we do it again on question 5 here. Alright, so here's my regular problem. Alright, 4, 1, 10, 4, 1, 10, 1, 4, 10, 1, 4, 10, and for the C, 3, 26, and 1. Alright, form the transpose. Alright, so we're coming this way. 4, 1, 10, column 4, 1, 10. 1, 4, 10, yes, 3, 26, 1. Got that. All right, so now let's get to our table. Y1, Y2, X1, X2, P. So 4, 1, 4, 1. Our slack variable has a 1, 0, 0, 3. What about this one? 1, 4, 1, 4. A slack variable is in X2, so 0, 1, 0, 26. P right now looks like that. If I get a 0, move all of this stuff to the left, minus 10, minus 10. This is a Y2, looks like it drifted up too much, equals 0. All right, so I'm looking here and I see the most negative. Well, I have a choice. It could be minus 10 or minus 10. I decided to pick this one simply because I'm looking ahead. Where's the smallest? 3 divided by 1 is 3. 26 divided by 4 is 6 point something. So this would be the smallest, and I already had a 1 there. You see, if I would have picked this column, which I could have, then I would have had 3 divided by 4, which is the smallest. But then I've got this 4, and I got to get fractions, and I didn't want to do that. So here's my pivot column, pivot row, got a 1. Now use the 1 to make some zeros. So minus 4 times row 2. Here's the row 2, so I'm going to add these together. I get my new row 2, so you can go through the addition. I need to get rid of the minus 10, so 10 times row 1. I'm going to add row 3. Here's row 3. And so now let's put everything back. All right, when I do that, I notice there are no more negatives in the bottom row. Therefore, we're done. What does it mean? All right, so here's x1, here's x2, 10, 0, and 30. So the minimum value is 30, and it's occurring at the point 10, 0. So not too hard, just take your time, don't make some kind of adding mistake, and I have confidence that you can do it.